Flexible cords such as SOOW can be used for power drops in an industrial facility provided that specific requirements are met. Firstly, flexible cord is designated for temporary power drops and not for permanent installations. Secondly, the flexible cord must have an appropriate voltage and current rating as well as be suited for the specific environmental conditions it will be exposed to. Thirdly, it must be well supported along its entire length to prevent any potential damage. Fourthly, measures must be taken to protect the cord from physical damage, chemical exposure, and the effects of vibration. Finally, always adhere to the manufacturer's guidelines and relevant electrical codes when utilizing flexible cords. When considering a permanent power drop, Sealtite conduit is often the recommended solution for industrial facilities that experience vibration or require equipment relocation. Flexible metal conduit, also known as FMC, can be an alternative option for permanent power drops, especially in areas where Sealtite installation is challenging. In situations involving vibrating machinery and potential relocation, utilizing Sealtite conduit offers the most reliable and secure method for establishing a permanent power drop. When employing flexible cords for temporary power, ensure they are clearly labeled as such. Regular inspection and maintenance of both cords and conduits are essential to identify any signs of damage and ensure they remain properly supported and protected. Make sure that the installation adheres to the requirements outlined in the National Electrical Code, or NEC, and any additional local regulations that may be in effect. Consider consulting with a qualified electrician to ensure accurate installation and ongoing maintenance. The NEC addresses flexible cord usage in Article 400. It outlines permitted and prohibited uses to ensure safety and prevent electrical hazards. Flexible cords are designed for connection to portable appliances, equipment, and devices. Their construction allows for repeated bending and flexing without damage to the conductors. Some of the permitted uses of flexible cords, according to the NEC, include pendants, wiring of luminaires, connection of portable lamps or appliances, elevator cables, wiring of cranes and hoists, connection of stationary equipment to facilitate frequent interchange or prevent the transmission of noise or vibration, appliances where the fastening means of attachment prevents operation without the flexible cord, data processing cables, and connection of moving parts. The NEC also specifies prohibited uses of flexible cords. They cannot be used as a substitute for the fixed wiring of a structure, run through holes in walls, ceilings, or floors, run through doorways, windows, or similar openings attached to building surfaces, or concealed behind building walls, ceilings, or floors. Flexible cords should not be installed in raceways except as otherwise permitted in the NEC. They also cannot be used where subject to physical damage. The ampacity of flexible cords is determined by NEC Table 400.5a. This table provides the allowable ampacities for various types of flexible cords based on their conductor size and temperature rating. It is crucial to select a flexible cord with an ampacity sufficient for the intended load to prevent overheating and potential fire hazards. Flexible cords must be protected from overcurrent using fuses or circuit breakers. The overcurrent protection device should be sized according to the ampacity of the flexible cord, as specified in NEC Table 400.5a. The NEC also requires that flexible cords be properly connected to devices and equipment using cord connectors or attachment plugs. These connectors must be designed to securely grip the cord and prevent strain on the conductors. Cord connectors and attachment plugs must be listed for the intended use. Strain relief is essential for flexible cords to prevent tension on the conductors at termination points. Strain relief can be provided by cord connectors, cable ties, or other means that securely anchor the cord. The NEC requires that flexible cords be supported to prevent excessive strain on the cord and its terminations. Support can be provided by cable ties, clamps, or other means that securely hold the cord in place. When flexible cords pass through holes in enclosures or equipment, they must be protected by bushings or grommets. These bushings or grommets prevent abrasion and damage to the cord insulation. Flexible cords must be protected from physical damage such as abrasion, cuts, and impact. Protection can be provided by using cords with a rugged outer jacket or by installing the cord in a protective sleeve or conduit. Flexible cords must be suitable for the environment in which they are used. For example, cords used in wet locations must be listed for wet locations. Cords used in hazardous locations must be listed for hazardous locations. Flexible cords must be properly maintained to ensure their continued safety and reliability. Regular inspections should be conducted to check for signs of damage such as cuts, abrasions, and exposed conductors. Damaged cords should be replaced immediately. When flexible cords are used in temporary wiring installations, they must comply with the requirements of NEC Article 590. This article provides additional safety requirements for temporary wiring, such as GFCI protection and secure support of cords. Sealtite, or liquid-tight flexible metal conduit, is a type of flexible conduit used in electrical installations to protect wiring from moisture, chemicals, and physical damage. It consists of a flexible metal core with a liquid-tight outer jacket. Sealtite is commonly used in industrial, commercial, and residential applications where wiring needs to be protected from harsh environments. Sealtite conduit must be properly supported to prevent sagging and damage. The NEC specifies the maximum spacing between supports for Sealtite conduit based on its size. Support should be installed at intervals of 3 feet or less for trade sizes 3/8 through 1 inch, 4 feet or less for trade sizes 1/4 through 2 inch, and 5 feet or less for trade sizes 2/2 through 4 inch. Sealtite conduit must be securely connected to electrical boxes and enclosures using listed connectors. These connectors provide a liquid-tight seal to prevent moisture from entering the enclosure. Connectors should be installed according to the manufacturer's instructions. Sealtite conduit must be properly grounded to ensure electrical safety. Grounding can be achieved by using a separate grounding conductor or by bonding the conduit to a grounded metal surface. The NEC specifies the grounding requirements for Sealtite conduit in Article 250. Sealtite conduit is available in various trade sizes ranging from 3/8 inch to 4 inches. The appropriate trade size depends on the number and size of conductors being installed. The NEC provides guidelines for selecting the correct conduit size based on the conductor fill. Sealtite conduit is suitable for use in wet locations provided that it is installed with listed liquid-tight connectors. The conduit and connectors must be resistant to moisture and corrosion. Sealtite conduit is also suitable for use in hazardous locations, provided that it is listed for the specific hazardous location. The conduit and connectors must be explosion-proof or intrinsically safe. Sealtite conduit can be bent to navigate around obstacles and make turns. However, the bending radius must not be less than the minimum bending radius specified by the manufacturer. Exceeding the minimum bending radius can damage the conduit and compromise its liquid-tight seal. Sealtite conduit should be inspected regularly for signs of damage, such as cracks, cuts, and corrosion. Damaged conduit should be replaced immediately to prevent electrical hazards. When installing Sealtite conduit, it is important to avoid over-tightening the connectors. Over-tightening can damage the conduit and compromise the liquid-tight seal. Connectors should be tightened to the manufacturer's recommended torque specifications. Sealtite conduit should not be used in applications where it is exposed to extreme temperatures. High temperatures can cause the conduit to soften and lose its liquid-tight seal. Low temperatures can cause the conduit to become brittle and crack. Sealtite conduit should be stored in a dry location to prevent corrosion. The conduit should be protected from direct sunlight and extreme temperatures. Sealtite conduit can be cut using a hacksaw or a conduit cutter. The cut should be clean and free of burrs to ensure a proper connection with the connector. When installing Sealtite conduit, it is important to follow all applicable codes and standards. The NEC provides detailed requirements for the installation of Sealtite conduit in Article 350. The choice between flexible cord and Sealtite depends on the specific application and the requirements of the electrical code. Flexible cords are suitable for temporary power drops and for connecting portable equipment, while Sealtite is preferred for permanent power drops and for protecting wiring in harsh environments. Flexible metal conduit, or FMC, is a type of flexible conduit used in electrical installations. It is made from a spirally wound strip of metal that forms a hollow tube. FMC is used to protect electrical wiring in locations where flexibility is required, such as in tight spaces or where equipment may be subject to movement or vibration. FMC is suitable for use in dry locations, but it is not suitable for use in wet locations unless it is specifically listed for wet locations. FMC is available in various trade sizes ranging from 1/2 inch to 4 inches. The appropriate trade size depends on the number and size of conductors being installed. FMC must be supported at intervals not exceeding 4.5 feet according to the NEC. This support helps to prevent sagging and damage to the conduit. FMC must be securely connected to electrical boxes and enclosures using listed connectors. These connectors provide a secure connection and prevent the conduit from pulling out. FMC must be properly grounded to ensure electrical safety. Grounding can be achieved by using a separate grounding conductor or by bonding the conduit to a grounded metal surface. FMC can be bent to navigate around obstacles and make turns. However, the bending radius must not be less than the minimum bending radius specified by the manufacturer. FMC should be inspected regularly for signs of damage such as dents, cracks, and corrosion. Damaged conduit should be replaced immediately to prevent electrical hazards. When installing FMC, it is important to avoid over-tightening the connectors. Over-tightening can damage the conduit and compromise its integrity. FMC should not be used in applications where it is exposed to extreme temperatures. High temperatures can cause the conduit to soften and lose its shape. Low temperatures can cause the conduit to become brittle and crack. FMC should be stored in a dry location to prevent corrosion. The conduit should be protected from direct sunlight and extreme temperatures. When installing FMC, it is important to follow all applicable codes and standards. The NEC provides detailed requirements for the installation of FMC in Article 348. The selection of the appropriate wiring method for a specific application depends on several factors, including the environment, the type of equipment being connected, and the requirements of the electrical code. It is important to carefully consider these factors to ensure a safe and reliable electrical installation. In industrial settings, where machinery often vibrates and is subject to relocation, the choice of wiring method is particularly important. Sealtite conduit is generally the preferred option for permanent power drops in these environments due to its durability and resistance to moisture, chemicals, and physical damage. Flexible cords may be used for temporary power drops, but they must be properly supported and protected to prevent damage. Ultimately, the best approach is to consult with a qualified electrician to determine the most suitable wiring method for the specific application. A qualified electrician can assess the environment, the equipment being connected, and the requirements of the electrical code to ensure a safe and compliant installation. They can also provide guidance on proper installation techniques and maintenance procedures. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. Working with electricity can result in serious injury or death if not done properly. Always follow safety precautions and consult with a qualified electrician if you have any questions or concerns. When dealing with electrical systems, safety is paramount. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable codes and standards. And never hesitate to ask for help if you are unsure about something.